Hey guys, welcome. This is our 4-5 video. We're going to start with vocab. As you can see, all of our vocab is right in this section. In fact, the best thing to do is just to copy down this picture right here. So this is what I would copy if I were you, right here. Basically, we're looking at what's called an isosceles triangle. Isosceles triangle have two congruent legs, and you can see the legs are denoted. And they also have two congruent bases. So these angles are congruent and the legs are congruent. And then the third angle, the one that's not a base angle, we call the vertex angle. Okay. So this is basically what we call an isosceles triangle. We see them all over the place. A lot of times pennants and things like that. So we get quite a few rules with them. So let's go ahead and take a look at our first kind of theorem that we get to look at, which is, it's written right here, but I'm going to go ahead and flip it over to the next page. Make sure you copy that picture now. Okay, so here's our first theorem, and this is probably one of our most important ones. It says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So if I say CA and BC are congruent, then I know the base angles are congruent. This is really important. Basically, it's kind of what the definition of an isosceles triangle is. As long as two are congruent, then the other two. Now, I'm going to save you some time. I want you to go ahead and write this down. However, we're going to see that this theorem is just the converse. So you can write this one a lot shorter. Again, we're just going to go ahead and remember, we have our normal conditionals like this. Our converse is just flipping the two statements. You can see my hands. So before we had two sides were congruent, then the two opposite angles were congruent. Now we're saying if we have the two angles of the triangle congruent, then the two opposite sides are going to be congruent. So it's just the converse. You guys can kind of make it a little bit shorter, but pretty easy. You have those two theorems back to back. Let's go ahead and take a look at a couple more things. This one right here, very important one to write down. If a line bisects, and remember the word bisects, nice purple right there. Bisects means to cut into two equal halves. So this angle is getting cut into two equal halves. One right there and one on the other side right there. So these are two equal halves that have been cut by the bisector, and if it is bisecting that vertex angle, then we know for a fact that it's also going to be a perpendicular bisector of the base. Okay? So if I bisect this, then this. Notice that we're still in those conditional sentences. If something happens, then something else happens. Okay, let's look at our next one, so make sure we write that one down. The last two are kind of not looking at the isosceles anymore. Now we're looking at something else. This is called an equilateral triangle. Equilateral would be this right here, where all sides are congruent. Then we know the triangle is equiangular. Okay. So this is true, and if it's equiangular, we know that all the angles are 60 degrees, right? 60 degrees for all of our angles. 60, 60, 60 makes 180 degrees. So if the triangle is equilateral, then the triangle is equiangular. And the last theorem, which you can write down, but you can kind of do it again shorter, is kind of the converse of that, which is if it's equiangular, then we know it's equilateral. So let's go ahead and jump into a quick example. I'm at my house by my way.
In this problem, you will use the
Sorry, that lady always talks. I don't know why. I'm going to mute so we can't listen to her anymore. Okay. So anyways, I'm at my house. My wife's cooking me food. It's awesome. Maybe you can guess what it is. I don't know. Anyway, here we go. Here's our problem. And we see this picture right here. And it says, is AB congruent to CB? So AB is right here. This segment here, is it congruent to BC? Okay. If you notice, the two angles at the bottom right here are congruent, and our converse of the isosceles triangle theorem said if the two base angles are congruent, then we know the opposite. So what's our answer? Well, the answer is true, and we're going to kind of go ahead and fast forward and see this. So I'll show you what we want to write here. But we see the base angles, and they're showing the base angles are congruent. And if that's true, So here's what they write, and this is what you're going to write. So C and A are congruent, so AB and CB are congruent by the converse of the Isosceles Triangle theorem. So this is how we know that this is true, right? So we're using that converse of the Isosceles Triangle theorem, and we just keep adding on those theorems more and more and more as we go. Okay? Let's take a look at part 2 of this. So it's kind of the same problem, but second part. Here we go. Is angle A, congruent to DEA? So the first thing, let's go ahead and identify DEA. Here's DEA. DEA, so DEA is this angle right in here. Okay, so are those two angles congruent? Well, I see that their sides are congruent, so triangle DAE is an isosceles triangle, so yes, we know they're isosceles because they have two congruent sides. Thus, we know that those two pieces are congruent there at the bottom. And so if we kind of scrub this forward a little bit more, we'll know that this is true because of the triangle, the isosceles triangle theorem. So there's our answer for part B. Okay, so make sure you get both of those pieces written down. All right, let's take a look at another problem here using algebra. Fun, fun, fun. Okay, all right. So it says, what is the value of x? So we're looking at this picture, and I see x in here. This actually looks like one of our isosceles triangles. So let's go ahead and see if we can diagnose and figure this out together. Well, if this is an isosceles triangle, then I know that these angles here are congruent. So if that's 54, this is also 54 over here, and you guys can just write down the work I'm doing for this one. So this is 54, this is 54. Now we had a special key concept earlier that said if the segment bisects the vertex angle. So this is our vertex right here. Wow, that was pretty crummy writing. Let's go ahead and write that a little bit better. If this is our vertex, then we know we're going to go ahead and bisect, which means this becomes a perpendicular bisector. Okay, so these show up. Well, now if we look at just a triangle with the x in it, so if I can kind of highlight that for you guys, BDC, this triangle here, I can actually redraw this triangle out here, which I'd like you to do. Everything that I draw, you want to draw down. This angle right here is 54 because it was a base angle to the angle right here. And we want to say, what is x? Okay, well, this looks like a pretty basic algebra problem for us. We're going to do x plus 90 plus 54 is going to equal 180 degrees. So we're just going to go ahead and add 90 and 154. That's going to be 144. And then we subtract it from 180. And we're going to get the value of 36. So x is 36 degrees. Okay? So kind of using that theorem, again, we're always applying our theorems in our pictures. Okay? Alright, last problem. It's kind of like a lot of problems here. Finding angle measure. This is a good one. This one's about our equilateral and equiangular picture. So here's our equilateral, equiangular. I'm going to just zoom it forward just a bit so we kind of get the picture alone by itself. So there we go. No, nope, 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 nope. I don't want to see that. I don't want to see that. No, stop. There we go. Okay. What are the measures of A, B, and ADC in the photo at the right? So my wife's hard at work making noise while she cooks. God bless her. Okay. Angle A, boom. We got angle A here. We got angle B, boom. And then we got, I should probably do those in different colors. Oh well. And then angle ADC. ADC is actually this full angle up here. Okay, so what are the measures of these angles? Alright, well, if we look slowly first, we see that this triangle in the orange I just drew is an equilateral. Actually, in fact, all of them are equilateral triangles, which means they're all equiangular. So I can go ahead and just say, hey, look at all of these angles are congruent. This is fantastic. Okay, and what we know is if all the angles are congruent, that means they're all 60 degrees. So angle A is just 60 degrees. Angle B is just, it's a single angle. It's just 60 degrees. The only one we have to be careful about is ADC, because ADC is actually a double angle. And if I kind of clear all the mess that I drew, and let's get a different color in there. Let's go sky blue. So here's this guy. ADC is actually a double angle. It goes from here to here. So it's two angles together. So it's not just 60, but it's 60 plus 60. So angle ADC, a little bit bigger, is going to be double, or 120 degrees. Okay, guys. That's it for the story. End of the video. And you can say hello to my little elephant buddy here. And my wife wanted to say hi.
Hey guys.
And that's it. Yep, she really does exist. You heard her. So, see you guys.